Welcome to the Yamaha Garage. Thanks for joining us today for some tips and useful pointers on maintaining your Yamaha. Today's tutorial is going to cover an important tool used for nearly all frequent maintenance tasks for any vehicle, not just your Yamaha. Today we're discussing how to properly use a torque wrench for tightening bolts to the proper torque spec. This will be an entry-level tutorial, a torque wrench 101 so to speak. We'll cover a few of the most common types of torque wrenches and each type's pros and cons. Why proper torquing is important. A little about the measurements that are used. We'll demonstrate the proper procedure for basic bolt tightening to a specified torque using a couple of different types of common torque wrenches, and provide some technical tips along the way. This video will not cover more advanced torque procedures such as torquing with angles, torquing multiple bolts in sequence or pattern, torquing with multi-stage specs, torquing with lubricated bolts, or use of dial torque wrenches. Please research other reference materials for more information if your manual calls for these more advanced torquing procedures. Now, let's take a look at a few different types of torque wrenches commonly used by our Yamaha technicians. There are 4 common types of torque wrenches best suited for servicing motorsports units: beam, clicker, digital, and adapter. We'll take a quick look at each, how they work, and each type's pros and cons, and then show you a couple of them in action. First up is the beam type. The bilateral beam of the beam torque wrench flexes along the scale to indicate the amount of torque applied by the user to tighten a fastener. To use a beam type, you simply tighten with the torque wrench until the needle on the beam's pointer indicates the desired torque. The advantage of a beam type torque wrench is simple. They're usually the least expensive and the easiest to use. The disadvantages? Because it's easy to accidentally overshoot the torque you're targeting, they tend to be the least accurate of all the types of torque wrenches described here. Also, sometimes it may be difficult to read the scale when working in tight areas. Next up is the clicker type. The clicker torque wrench uses a spring-loaded fulcrum that breaks free and creates an audible click when the preset torque is achieved. To use a clicker, you preset the desired torque by twisting the handle until the scale in the body of the torque wrench is set to the desired torque. Turn the torque wrench until the ratchet head breaks free and you hear the audible click. The advantages of clicker type torque wrenches are they offer accuracy while still being economical to purchase. These are the most common type used in the market and can be purchased almost anywhere quality tools are sold. A disadvantage is a clicker type torque wrench can fall out of calibration over time due to the internal tension spring weakening. Note, if you opt for a clicker, you can ease the tension on the spring and help maintain calibration longer by always turning the setting back to 0 after each use. Third, we have the digital type. Digital torque wrenches utilize an electronic sensor to measure the amount of torque applied by the user and makes an audible beep and/or vibration when the pre-entered torque is reached. With most digital wrenches, you turn the wrench on, then preset the desired torque by using up and down arrows on the tool to set the desired torque. Turn the torque wrench until the ratchet head breaks free and an audible beep is heard and/or a vibration is felt. The advantages of digital type torque wrenches are that they offer the most accuracy and often also have a function to do angle torques. These also do not need to be reset to 0 after use. The disadvantages are they tend to be the most expensive. They may require the user manual to work through the settings menu, and they require batteries, which can add some level of inconvenience. And lastly is a newer style adjustable digital adapter. It works by separating the electronics from the handle, allowing you to use any common ratchet handle, much like a digital type torque wrench. These also signal with an audible beep when your preset is reached. The advantage of a digital adapter type torque wrench is they offer all the accuracy of a digital type torque wrench, but at a much lower cost since you'll be providing the handle from your own toolbox. The disadvantages are adding the electronic box to your standard ratchet could complicate accessing certain bolts. They also can have complicated menu settings and require battery maintenance. There are benefits and trade-offs to each type, such as cost and accuracy, but for most routine maintenance jobs, using any torque wrench is better than not using one at all. So why is torquing to the proper specification so important? Well, it's obvious why nuts and bolts need to be tightened. Loose fasteners can be the cause of leaks, internal part failures, or parts falling off. But over-tightening can also lead to problems such as cracks, warping, stripping, or bolt snapping. So engineers provide us with the proper tightening force for critical fasteners. The most common parameters that determine the given torque spec are based on the fastener's size, material, load, location, and purpose. The units of torque used in Yamaha manuals are measured and written as either Newton meters, which is the metric designation, or pound feet, also referred to as foot pounds, which is the SAE designation. 1 Newton meter is equal to 0.74 pound feet, and 10 Newton meters is the equivalent of 7.4 pound feet of torque. 1 pound foot is equal to 1.36 Newton meters, and 10 pound feet are the equivalent of 13.56 Newton meters. Hand tight is on average 2 to 4 pound feet. Now let's grab a couple different types of torque wrenches and show you how to properly use them. We'll demonstrate the torquing procedure first using a clicker type torque wrench, and then we'll do the same procedure with a digital type torque wrench. First, the obvious. Let's find the correct socket set to fit the drive of your torque wrench. Wrenches with a 1/4 inch drive are best used for small bolts with low torque values, like 5 to 20 foot-pounds. 1/2 inch drives are for large bolts, like axle nuts, for instance, or bolts with high torque values, say over 100 foot-pounds. The most common drive for motorsport vehicles is the middle 3/8 inch drive, like we have here. Next, and of critical importance, is using the proper socket for the fastener you're tightening. An improper socket size can lead to stripping the bolt head, making it impossible to tighten the bolt, and almost as frustrating, difficult to loosen the bolt to replace it. Take your time, find the right size. You'll know it's the right size if it fits tightly and has no slop. And know that you should never use a torque wrench to loosen a bolt. It is a precision tool for tightening only. Now let's grab our clicker torque wrench here and get to some proper tightening in a few easy steps. First, find and unlock your wrench. The lock on ours is here on the ring on the handle. Second, set the wrench according to the torque spec in the owner's or service manual for your vehicle. In our case, this drain bolt for an XT250 is 15 foot-pounds. Next, lock the wrench. Place the wrench and socket on the bolt. Place one hand loosely on the head of the wrench and socket only to help to maintain a perpendicular angle. Be careful not to grip the socket tightly or inhibit the motion of the handle in any way, as this will negatively affect the true torque you are applying. With your other hand on the end of the handle, smoothly pull the handle in one tightening motion until you hear an audible click. Note that sometimes it may take a couple of pulls to get the final pull that yields the click that signals your correct torque is set. Just remember, as you get close, you must be moving through the click to correctly achieve the specified torque. The last step, if you're not going to continue immediately using your click torque wrench, is to unlock it and set it to 0 and lock it again for storage. And don't forget to remove the socket. Next, we'll show you the same procedure using a digital torque wrench, noting that the digital adapters work the same. First, hit the power button on your wrench. Remember to check the batteries first if it does not turn on. Second, use your wrench's menu function to select measurement in either foot-pounds or Newton meters. We'll select foot-pounds here. Next, we need to set the torque spec number. Again, the owner's manual for this XT250 asks for 15 foot-pounds for this drain bolt, so we'll use the Set button to enter that spec. Place the wrench and socket on the bolt. Place one hand loosely on the head of the wrench and socket again, just to help maintain a perpendicular angle. Be careful not to apply pressure to the socket or inhibit the motion. With your other hand on the end of the handle, smoothly pull the handle in one tightening motion until you hear an audible beep. Some digital wrenches have an LED light that will flash or vibrate as well. Note again that sometimes it may take a couple of pulls to get the final pull that yields the beep that signals your correct torque is set. Again, remember that you must be moving through the beep to correctly achieve the specified torque. The last step, if you're not going to continue immediately using your digital torque wrench, is to turn it off and store it securely, remembering that it is a precision instrument. And remember to remove that socket. If you do not plan to use your digital wrench for a month or more, we recommend removing the batteries and keeping them in the case ready to reinstall before your next use. One last thing to note about torque wrenches. They all have the tendency to lose their accuracy over time, and because they are a precision measuring tool, they do require routine calibration. The accepted industry standard suggests recalibration after 5,000 cycles or every 12 months. However, usage and tools vary greatly, so check what the manufacturer's manual says about your specific tool. Thanks for watching, and make sure to check out the Yamaha YouTube channel for more do-it-yourself videos and technical tips. Now let's get out and ride.